right. Well, first, let me thank the Sacramento Valley Astronomical Society for inviting me to be with you this evening. The idea of having me speak to you came up a year ago at the Astronomical League Convention in Albuquerque, where I gave a version of this talk. And I was asked if I would share it with you, and I said sure. And then it took a year for the scheduling to work out, but here we are, and I appreciate it. I'm on the East Coast in New Hampshire, so I'm 3 hours ahead of you, which means it's pretty late here. So if I fall asleep during my own presentation, you'll understand why. Hopefully nobody else will fall asleep during my presentation. So I'm going to talk about a new era of professional amateur collaboration in astronomy. And so before I go into it in any detail, I want to make sure I can advance my slides. There we go. I want to offer some definitions. So, what is a professional? What is an amateur? So a professional is someone who, is engaged in a profession, typically one that they have to study and study for and maybe get licensed in. It's somebody who follows who conforms to the technical and ethical standards of a profession, and it's someone who typically is working in this field for their livelihood, for pay. So I like to change the professional to professional with dollar signs in it, because that's the key thing about a professional in astronomy or anything else is that they're typically earning their living doing it. An amateur, on the other hand, is someone who may be engaged in the same field, but they're doing it as a pastime, as a pursuit, because they enjoy it, they admire it, they love it, right? The Latin root of the word amateur is the same word, the same root of the word love. So sometimes I'm asked, are you a professional astronomer or an amateur astronomer? And my answer is yes, because I'm really both. I've spent the better part of my life as an amateur astronomer, but I've also, gotten my PhD and worked for pay in the field for almost 40 years now. Although I just retired, so I guess I don't know if I'm a professional anymore, except that since I now get royalties for my book, I guess you could say, yeah, I'm still doing it for money. So I like to think of ProAm collaboration as something that you can divide up in history into various time periods. And each of these time periods, the flavor of professionals and amateurs collaborating in astronomy has been different. So for the first era, which is basically prehistory through the middle of the 19th century, there was almost no distinction between professionals and amateurs, at least when it came to observing and trying to understand the universe. The only people who made money as astronomers were typically teachers, usually at the college or university level. And of course, even that's, a fairly recent invention. But by the late 19th century,
oh, he just dropped out.
Dr. Feinberg.
I'm back.
You're back now.
Yeah, let me share my screen again. Sorry, this may happen occasionally because I have a fairly cruddy rural internet bandwidth or lack thereof. We are going to get higher speed internet soon, but we don't have it yet. So bear with me. All right, so you heard me talk about the first era of ProAm collaboration when there was hardly any distinction between amateurs and professionals. Now, as we get to the late 19th century and into the early 20th century, three advances began to cause professionals and amateurs to diverge. And those were photography, which unlike today, was a very laborious process that only was accessible to professional astronomers. Spectroscopy, which was a new development in the late 19th century as well. And also the beginning of a period of building larger and larger telescopes, primarily reflectors. And the fact that astronomers had access to photography, spectroscopy, and what at the time were very large telescopes that created this diversion between professionals and amateurs. So it was around the same time that the American Astronomical Society was founded. Astronomy was becoming a profession in the US as a result of these three trends. And you probably, hopefully recognize at least some of these people, if not by their photograph, at least by their name. These are some of the most prominent astronomers in the late 19th century, and they were the original founders of the AAS, the American Astronomical Society, in 1899. So next year, we're going to have our 125th anniversary. And we're having a big total eclipse across the country to celebrate. So when the AAS was founded, the question came up, well, should we include amateurs? And James Keeler wanted to exclude amateurs and create a purely professional organization. But the way the constitution of the society was written, it said members simply should be capable of producing an acceptable paper. And at the time, in 1899, there were still plenty of amateurs, people who weren't employed as astronomers, who were producing really good research, comparable to that of some of the professionals. And so 15% roughly of the society was actually amateur astronomers. And that's a pretty significant chunk. About 15, 16 years later, some proposed, well, now that there's really a pretty significant distinction between amateurs and professionals, keep in mind that in 1916, the Mount Wilson 100-inch was just about to come online. So, amateurs didn't have 100-inch telescopes. They proposed creating two classes, a professional or a full membership class and an amateur or associate membership class. But Pickering, who was one of the leading voices in the society, really didn't like this proposal, and he managed to get it voted down. So what is the AAS today? It's a nonprofit organization headquartered in Washington, D.C. For the whole 12 years that I worked for them, I worked remotely. I was, you could call me a pioneer, because I was working remotely before most people were working remotely. But now, of the roughly 30 full-time staff, about a third of them work remotely. So it's not a, it's not a strange thing anymore, obviously, especially after the pandemic. We have a membership of about 8,000 astronomers, which is nearly half of the International Astronomical Union. The AAS accounts for a very disproportionately large number of IAU members. And there's a number of part-time journal editors and various contractors, like our IT people, things like that. I'll say a little bit more about some of them in a minute. The society welcomes astronomers in every field of astronomy, and it has 6 topical divisions listed here, each of whom has their own meetings, and in some cases even their own journals. And so, that you see these are covering almost every area of astronomy that you could imagine. So what does the society do? Well, its mission is to enhance and share humanity's scientific understanding of the universe. And those two verbs are really important. Enhancing our scientific understanding of the universe is, through meetings and publishing and that kind of thing. It's basically, advancing the science. Sharing our scientific understanding is where education and outreach and also publishing come in. So let me give a real quick rundown of our major activities. We have 2 annual meetings, one in January and one in June. We have an advocacy arm. We have a director of public policy and a public policy fellow who organize, it's not lobbying exactly, because lobbying is usually for a specific purpose or thing and involves sometimes giving money. We don't do that. We advocate. We don't call it lobbying. We call it advocating. And we typically will train our members to advocate on Capitol Hill for good funding of science generally. We don't like to send our members to the Hill to argue in favor of this or that astronomical project, because if you're arguing for one project, that is effectively the same as arguing against some other one because there's only a limited amount of funding. So we try to advocate for the health of the field in general. Media relations was my job at the AAS. Here I am pictured running one of the press conferences at our annual meetings. We give awards and prizes to recognize excellence in research and education, instrument development, and other areas. We do some direct education and outreach with the public. So here, for example, we've got kids that we've invited, local school kids, to come to our meeting and interact with astronomers and play with some of our technology. But the main thing we do in education is to train our members to be more effective teachers and to engage more effectively with the public. Professional development are things like teaching graduate students to operate telescopes and other instrumentation, to run various software packages, things like that. And then one of our major activities is publishing. We publish 7 journals. Several of them are among the largest circulation journals in astronomy and in the astronomical sciences. And more recently, we began publishing for amateurs and interested enthusiasts because we now publish Sky and Telescope magazine, as well as books formerly under the Wilman Bell imprint. And I'll say more about both of those later too. But that added about a dozen staffers. It took the AAS from low 20s to low 30s in terms of its total staffing. And of course, the staff of Sky and Telescope is based in Cambridge, which is why I'm still in New England, because after I finished my work at Harvard, I started working at Sky and Telescope, and that kept me in Cambridge. All right, so let's move on to the other eras of ProAm collaboration. So early 20th century, the amateur membership began to dwindle in terms of absolute numbers and percentage of the AAS as a whole. But it was also a period when separate organizations were being formed, things like the American Association of Variable Star Observers. And these were designed to coordinate the work of skilled amateurs in supporting professional astronomy. And these organizations were typically led by professionals as well. So amateurs are being recognized for their ability to contribute to the science, but they're being kind of shunted off into separate organizations from the AAS. And for most of the 20th century, which those of a certain age will have lived through and will remember well, amateurs were contributing to research primarily through visual observations, discovering comets, asteroids, other transients like novae and supernovae, monitoring the planets, measuring meteor showers, things like that. And you had more organizations of amateurs doing serious work formed throughout the 20th century. So the Astronomical League in the mid-40s, the ALPO, the Association of Lunar and Planetary Observers in 47, and this crazy thing called the IAPPP, which was the International Amateur Professional Photoelectric Photometry. And they left off the last word. It's not society or organization. It's kind of weird. But they eventually changed their name to the Society for Astronomical Sciences, which is a lot more sensible. So during this era, you had some superstars. Among them were Reverend Robert Evans in Australia. He was notching supernova discoveries year after year, and he was doing this entirely visually. You know, he remembered what hundreds of galaxies looked like, and so he could, when he would swing his telescope to one of these galaxies, if there was something there that he hadn't seen before, he knew it was a supernova. And he was one of the most prolific supernova discoverers in the late 20th century. David Levy is a name everybody knows. If you don't know him personally, you've heard of him because of Comet Shoemaker-Levy 9, which crashed into Jupiter in the early 90s. David was, like Robert Evans, only with comets. He either on his own or with Carolyn and Gene Shoemaker has discovered something like 20 plus comets over his career. So you had these superstars, but you had lots of other people also discovering comets and supernovae, and you had lots of people measuring variable star changes of brightness and so on. It was almost all visual, some photographic work. Also during this period, amateur telescope making really took off. And I like to point out that it's not just amateurs building telescopes, but there's a lot of innovation that was going on. So for example, John Dobson introduced this whole new category of telescopes, which were large Newtonian reflectors on very simple, very easy to use mounts. And thanks to him, the apertures available to amateur astronomers, skyrocketed in the last couple decades of the 20th century. It used to be that a 10-inch was a big telescope, but by the end of the 20th century, a 10-inch was a pretty modest telescope, and a 16 or a 20 or even a 24-inch telescope was not that uncommon. So one of my favorite things to happen during the middle of the 20th century was the founding of Sky and Telescope, right before the outbreak of World War II, or at least the outbreak as far as the US was concerned. And Astronomy magazine followed some years later, August of 1973. Astronomy is celebrating their 50th anniversary this year. Their 50th anniversary just showed up, or their 50th anniversary issue just showed up. Sky and Telescope has had its 80th anniversary a couple of years ago, and its next milestone is the 1000th issue of Sky and Telescope, which is, I believe, it's either at the end of 2024 or the beginning of 2025. I forget. That'll be a big deal too. The 1000th issue of Sky and Tel. And these magazines, one of the main functions was to provide a communications conduit between amateurs and professionals. A lot of professionals write for these magazines to share the latest scientific research with amateurs. But a lot of professionals become aware of the work that amateurs are capable of by seeing the amateur work published in Sky and Telescope. And amateurs, of course, are finding out what professionals are doing. So it's a really great communications conduit. Now, by dint of the fact that there's, at least 10 times more amateurs than there are professionals, most of the readership of these magazines is amateur astronomers, but the professionals read them too. All right. So it was also in the mid to late 20th century that commercial telescopes began to proliferate. If you were a hobbyist in the 40s and 50s and you wanted a telescope, you pretty much had to build it. But then by the 70s and 80s, the availability of all different kinds of commercial telescopes made it a lot easier for people to get into astronomy. And the readership of the magazines skyrocketed, and the number of amateurs who were observing the sky skyrocketed too, because you no longer had to build a telescope to be able to participate in the hobby as an observer. And the Schmidt-Cassegrain played a particularly important role here because it was highly portable, and it had much bigger apertures than people typically had, certainly bigger apertures than you had with refractors. The smallest Celestron telescope for many years was an 8-inch, and you could buy even a 14-inch, which was unheard of in the 70s. So the AAS eventually did create multiple membership classes, starting out with the ones listed here. You'll notice they're distinguishing different phases of a professional's career. They didn't have a separate class for amateurs. Amateurs were allowed to become members if they wanted to by applying for associate membership, but the price was kind of prohibitive. And the AAS didn't do any outreach to the amateur community to encourage them to join, to encourage amateurs to join, and so very few did. So the modern era, the era that we're in right now, which began in the late 80s, is the era when technology changed everything in amateur astronomy. When you look at the list of all the things that have become common only over the last few decades, it's really quite remarkable. You know, we went from photography to digital cameras. We started getting spectrographs. We had the incredible power of the personal computer. Now we have mobile phones and tablets. You know, you can control a telescope with your mobile phone. You've got GPS. You've got telescopes that can figure out where they're pointing without any input from the user. A couple things I wanted to call attention to here because I'll bring them up again. I list active optics. Some manufacturers have produced accessories for telescopes that they have called adaptive optics, but that's not really true. Active optics control, or they allow you to tip and tilt a mirror so that you can keep the image in one spot instead of having it jump all over the field of view. But true adaptive optics is when you compensate for the seeing, for the fact that your images are degraded in resolution. And there have not been any instruments available to amateurs to do that yet. And then the last item on the list, which is the most recent one that I added, was what I call intelligent imaging systems or smart telescopes. These are things like the unistellar EV scope and the Stellina or the Vespera from the company Vaonis in France. These are systems that you basically put down on the ground or on a tripod. You flip the switch, you control them with your smartphone. They do everything. They can find the objects, they can center them, they can track them. They take images, beautiful digital images in color and send them right to your mobile device. These things started out pretty expensive. The EV scope is still more than $4,000. But just in the last few weeks, two companies have announced products that are selling that do this for just a few $100s. So it's amazing how fast the prices of the newest technologies come down. And I'm going to bring both of these things up again later because they figure in what's happening now and what I think will be happening in the future. So once you had CCD cameras and the internet, you had things like Tim Puckett's Puckett Observatory Supernova Search. He had this giant, I don't know, I think it's a 32-inch telescope that he built. You know, you can tell just by looking at it, it's quite an amazing feat of amateur telescope making. But he connected this telescope to the internet with a real powerful CCD camera, and he had a group of dozens of people who were taking images of galaxies and finding supernovae in them, using software to compare, you know, the original image to the latest image. And Tim Puckett superseded Reverend Robert Evans as a, you know, supernova discoverer of great note because the Puckett Observatory Supernova Search was becoming one of the most prolific finders of supernovae in the 90s and early 2000s, thanks to all of this new technology that was available to amateurs. So now amateurs have all these really complex setups. This latest one here, this is what my observatory looks like. Unfortunately, those clouds are pretty typical. I don't get as many clear nights as I'd like, but I've got solar telescopes. I've got a big aperture Schmidt cast for visual work. I've got a CCD equipped 8-inch telescope. I've got a beautiful Apo refractor. They're all on computerized mounts. I can control 3 out of the 4 of them with my phone or my iPad. It's just amazing. And this is all off the shelf stuff. The only thing I built was the observatory itself. I've never built a telescope. I'm not proud of that. I actually would love to build a telescope someday. But as you can tell, I have enough telescopes. So by the late 80s, professionals were beginning to recognize that amateur astronomers had capabilities that they hadn't had before, and that they were beginning to do some real good science. And so organizations like the International Astronomical Union would occasionally have a conference where amateurs and professionals were both invited to talk shop and to learn about how they might work together to advance the science of astronomy. So the IAU had a conference in 1987. The Astronomical Society of the Pacific took advantage of the fact that a lot of amateurs and professionals were heading to Mexico for the 1991 eclipse, and they held a symposium on research amateur astronomy in Mexico right after the eclipse, or maybe it was before, I don't remember. The AAS was a little slow to jump on the bandwagon, but when they did, it was motivated by one of our divisions, the Division for Planetary Sciences. They had a workshop at one of their meetings in October of '98 to explore opportunities to increase ProAm collaboration in planetary science. And they actually proposed to the AAS that the larger society, the parent society, create a working group on ProAm collaboration. That proposal was accepted, and the 5-year charter was created, and the membership was drawn from various organizations, this alphabet soup, AAVSO, ALPO, et cetera, that were already doing professional amateur collaboration. And the idea was to figure out how to do that on a broader, larger scale and more effectively. So by the beginning of the 21st century, they were beginning to hold workshops on advanced observing techniques where professionals would train amateurs to get the kind of data that the professionals could use to do scientific research. So this is when you started, learning all about the importance of flat fields and dark frames and bias frames and calibration and all the rest of it. The working group was renewed for another 5 years after its initial charter expired. And during the same period, we had the emergence of all kinds of wonderful software tools and books that would support amateurs in doing not just imaging for fun, to make pretty pictures, but also imaging for science, doing light curves and doing other kinds of imaging that you could analyze scientifically. And the people who were writing these books and writing the software were no less innovative than the people who were developing some of the great technologies that, for telescope making and new kinds of accessories that people were inventing. Other books came out that were specifically targeted at amateurs interested in doing scientific research. And so you not only have the projects that you might want to do, but you also have the hardware, the physical technology, you also have the software and the algorithms that you need to process the data yourself. Or you can just hook up with professionals and take the data in a way that guarantees that they're scientifically of high quality, and then let the professionals analyze them on their own. But still, there was just tons of information available and resources to support amateurs doing science. And so the scientists recognized that amateurs were now able to contribute, and they started coming up with new ways to do that. This whole field of citizen science, which didn't really exist, at least not in astronomy, until earlier this century, it really came on the scene around 2007 with a program called Galaxy Zoo. There was a sky survey, the Sloan Sky Survey, that had tens of thousands of images and had hundreds of thousands of galaxies in those images that needed to be classified for the purpose of studying galaxy evolution through time in the universe. And the scientists who were running that, who included Chris Lintott in the UK and Kevin Shawinski here in the US, realized that they would never be able to classify all those galaxies on their own. And they hit upon the idea of putting the images online and asking the amateur community to classify the galaxies. Now, of course, to do that, they needed to train the amateurs to recognize the different types of galaxies. And what they did was they created an online training that anybody could basically complete. Didn't take very long. because they were just asking them to discern the shapes of galaxies. But then once you went through the training, then they turned you loose. And it was, one of the original types of crowdsourcing on the internet. It may be that some people would do a better job than others, but since you've got lots and lots of people classifying galaxies in the same images, you're building up a statistical, distribution of classifications, and you can pretty well trust that that the crowd will come up with the right classification, even though there will be some outliers and not everybody will agree. Nowadays, there are dozens of astronomy projects in what is now called the Zooniverse. And there are many other kinds of projects too, birding projects and projects, ecological and environmental projects. Scientists discovered that that when you put up a project like this, you will get not thousands or even tens of thousands, but potentially hundreds of thousands of volunteers. They won't all be amateur astronomers. Many of them, in fact, the majority, are not amateur astronomers. They're just enthusiasts. And the reason that they want to participate is because they're excited by the science and they want and they get a feeling of pride knowing that they're contributing to the advancement of science. So it's really amazing. We've unleashed the power of the population to do all kinds of interesting science. And they're doing it because humans are really good at pattern recognition. Now, I can imagine that a couple of years from now, given how fast artificial intelligence is moving, that I won't be able to say this anymore. Right now, humans are better at pattern recognition than computers. And the Galaxy Zoo project didn't start until after the astronomers tried to get a computer to do the classification. And they just found that it was too hard to get the computer to do it reliably. But people looking at the images were able to do it very reliably. And that's true across the board in a lot of different sciences. But I suspect that a few years down the road, processes like classifying shapes of things in images or identifying certain types of features in images, whether they're astronomical or otherwise, computers will be better at it than humans, thanks to artificial intelligence. But we're not there yet. So humans still have the edge in some areas. Now, you know that citizen science must be a real thing because now NASA is doing it too. And in fact, some of the projects that NASA does for citizen science are done through Zooniverse, but some are just done through NASA. A lot of them involve studying data from NASA missions. So here's just a short list of some of the notable results that have come out of citizen science. I'm sure many of these are familiar to you. The one that I added most recently is at the bottom. It was citizen scientists through the GLOBE project that demonstrated that satellite observations of light pollution, showing that light pollution is growing worldwide about 2% a year, are not correct. Measurements from the ground, which is where light pollution affects our observations, show that light pollution is actually increasing 10% per year, at least over cities. And that really came as a shock and a wake-up call. And one of the interesting characteristics of citizen science is whenever you see a list like this of citizen science results, you know that the papers that were published in the refereed journals about these different discoveries included many citizen scientist authors. So you remember that the AAS's original requirement was that to be a AAS member, you had to be able to publish a scientific paper in a journal. And many, many papers that are being published these days in astronomy and other fields that involve citizen scientists have citizen scientists as co-authors. So that's pretty cool too. So professionals, as I said, have now recognized that Amateurs are able to to contribute very meaningfully to research. And in 2006, the AAS established this award, the Chambles Amateur Achievement Award, for an achievement in research by an amateur astronomer. And again, this goes to the definition. It's a person not employed in the field in a professional capacity. Here's a list of the recipients of this Amateur Achievement Award. They run the gamut from asteroid work to exoplanet work to wide field astrophotography to a really great recreation of Einstein's or of the discovery of the bending of light during a solar eclipse that clinched the reality of general relativity for Einstein back in 1919. One thing that's interesting, if you look at this list, is there's a number of years in which no award was given. Now, is that because there aren't enough amateurs doing good research to justify giving out an award? No, it's a much more prosaic reason. There were no recipients in these years because there was a lack of nominations. So this is my call to you, the amateurs, to nominate people who you think are doing really good work, contributing to the astronomical sciences. You can even nominate yourself. Now, unfortunately, for the timing of this talk, nominations are due June 30th each year, so the nominations for this year have closed. But I'm hoping that there were some good nominations of amateur astronomers and that there will be an award given in 2023, because it's been 3 years since an award was given. And that's not right, because amateurs have been doing phenomenally great work over these last few years. So by the end of the first decade of the century, the working group on ProAm collaboration was disbanded because they were no longer needed. ProAm collaboration had become mainstream. Between the work that amateurs were doing with their great technology and the work that citizen scientists were doing, it was clear that amateur contributions to the profession of astronomy were widespread and real and significant. And so the working group declared victory and packed up. In 2016, the AAS established a governance task force to review the bylaws for the society, which hadn't been updated in decades, and also to look at membership classes and requirements. And the task force recommended that among the various classes of membership or affiliate membership, there should be a class specifically for amateur astronomers. And that class is called the Amateur Affiliate. If you go to the AAS website, aas.org, and you click on the join link at upper right, you'll find a number of choices, one of which is the different classes of membership. And if you scroll down, you'll find the Amateur Affiliate. And you'll see that for last year, the dues were $53. They're $53 again this year. Anybody who advances the astronomical sciences through research, communication, advocacy, but doesn't depend on research or education in astronomy for their profession, can become an amateur. They should be members of an organization, whether it's an astronomy club or a citizen science project or an advocacy group or any other association that facilitates ProAm collaboration. They're welcome to become members. And as of right now, we have about 300 amateur affiliates in the society. Since the society has 8,000 people, that's a pretty small percentage, but the number is growing. So in 2019, we got word that Sky and Telescope was threatened with being shut down because its parent company had gone bankrupt. Now, the parent company didn't go bankrupt because of Sky and Telescope. They were a company that owned about 60 different magazine titles, and Sky and Telescope was profitable, as it had always been, but many of the other magazines weren't profitable. And so the company as a whole was losing money and eventually declared bankruptcy. And I came up with the idea that maybe the AAS, which already is doing publishing and which is now welcoming amateur astronomers as members, would be a good place to publish Sky and Telescope. And I was surprised and delighted when the leadership of the society agreed that that was a good idea and successfully acquired the magazine. So for me, career-wise, it's like everything came full circle. I started my career at Sky and Telescope, and I moved to the AAS, and now they're merged. So the amateur affiliate membership class was established, and a task force was created to come up with some recommendations for, what kind of benefits the AAS should provide to attract amateur members, how they should be recruited, ideas for convening amateurs and professionals together so that they could, interact with each other in meaningful ways, whether at pre-existing AAS meetings or at special meetings or workshops designed to bring them together. And any other ideas on how the society could better engage with the amateur community. So it's been over 100 years, approaching 125 years, and just as amateurs were welcomed to the society in its early days, they're welcomed again. So the task force did a survey of the people who signed up immediately to become amateur affiliates, as well as other amateurs whose email addresses we had through Sky and Telescope, either as subscribers or as people who were receiving their weekly email newsletter. And among the results, these are not surprising. Clearly, the amateur affiliates are more experienced amateur astronomers than the typical amateur astronomer. And amateur affiliates are more engaged in the community through, for example, astronomy clubs than typical amateur astronomers. So the task force submitted a number of recommendations, and the board accepted them. And so these are now getting close to 2 years ago, but the recommendations included things like having a mentorship program for professionals or other amateur affiliates to train amateur members to do scientific research, to have stronger partnerships with this alphabet soup of amateur organizations, to develop a mechanism to link professionals who need amateurs' assistance and amateurs who want to work with professionals, figure out how to get them to find each other, sort of a matchmaker service, and for us to become more of a sponsor and exhibitor at large amateur conventions to make it clear to the amateur community that the professionals respect them and are interested in working with them as partners. So the recommendations are currently well, they've been accepted, but they haven't all been implemented yet. That's something that I'm hoping will happen in the very near future. So then, only a couple of years after acquiring Sky and Telescope, the AAS acquired Wilman Bell's inventory of astronomy books. It was a great fit because Wilman Bell had been publishing books for advanced amateur astronomers and professionals. And with the AAS having Sky and Telescope and its Shop at Sky online store, it made really good sense for us to be able to start selling Wilman Bell books. We're also going to be publishing new titles. So, for example, Jeff Knight's Annals of the Deep Sky, which he had published 7 volumes with Wilman Bell before the owners retired. The 8th edition, or the 8th volume, came out under the AAS. The 9th volume is at the printer now, and subsequent volumes will be appearing in the coming years. We've also accepted several book proposals, and so have some new Wilman Bell books coming out in the next few years. Sky and Telescope, under the ownership of the AAS, launched some new columns, one of which is a bi-monthly column on ProAm collaboration, not surprisingly. And it has covered a whole variety of different topics so far, including these listed here. So if you get Sky and Telescope, this column, it's typically 1 page, sometimes 2. It introduces the variety of projects that amateurs are able to contribute to in terms of scientific research, and usually introduces some of the people who are doing some of the most cutting edge work, so that you can figure out who you might want to get in touch with to learn more about it. So what's the next era of ProAm collaboration? We're getting near the end here. So I've always maintained that today's amateurs have better equipment than yesterday's professionals. This new technology, I shared a list with you, it just keeps coming, and it makes small telescopes perform like bigger ones used to. So that means that tomorrow's amateurs will have better equipment than today's professionals. Now, that doesn't mean that we're going to have 10-meter telescopes. It doesn't mean that we're going to have gigapixel CCD cameras or CMOS cameras. What it does mean is that we're going to be able to do a lot more science than we have been able to do up to this point, and continue to contribute in meaningful ways to the advancement of astronomy. So here's an example of one of the newest technologies that is enabling more amateurs and even people who don't really know that much about astronomy to contribute to the science, this EV scope, or enhanced vision scope, from Unistellar. The thing that separates this telescope from some of the others that have come along around the same time is that it was developed in conjunction with scientists at the SETI Institute with the express purpose of making the telescope, making the network of telescopes owned by amateurs and others throughout the world into a network of scientists, of citizen scientists able to contribute data, which the SETI Institute scientists would then process. And it's for things like asteroid occultations, exoplanet transits, discovery and tracking of near-Earth objects, things like that. So I reviewed the EV scope for Sky and Telescope a couple of years ago. And as part of my review process, I decided, well, let me see if I can do some science with this little 4-inch telescope. And I actually spent a night taking images of an exoplanet host star, this TOI object here. It's a TESS object of interest. TESS is NASA's Transiting Exoplanet Survey Satellite, and a TOI is a star that's been discovered to have a exoplanet candidate orbiting it. And so TESS only looked at stars for a month, which meant that if the planet was going around it in an orbit of a few weeks, it might catch one transit, or preferably two. With two transits, you have some idea of the orbital period, but you're not absolutely sure you've got a discovery until you see a third transit and a fourth transit. So that's where the amateurs come in, is we look at the TESS objects of interest with a telescope and a camera and measure a light curve and see when the transits occur or if they occur. And that helps confirm the discovery. So I looked at this obscure TOI, and I measured a light curve with the EV scope. All I did was tell the EV scope where this candidate planet is. It found it, started tracking it, didn't find the planet, it found the host star, of course, and tracked it and took a series of images all night long. And the data, I uploaded the data to the SETI Institute, and a couple of days later, they sent me this beautiful graph saying, look, you saw the transit. With a 4-inch telescope in my backyard, I measured a less than 2% change in the brightness of this star as an exoplanet transited its face. Pretty remarkable. And citizen scientists are doing this with EV scopes night after night. Now, while we have this capability, the professionals are on the verge, well, they're already doing it. They're already doing all-sky surveys that are finding more supernovae, more comets, more variable stars than amateurs could ever hope to find, either visually or through photography. And the next big survey to launch will be the Legacy Survey of Space and Time by the Vera Rubin Observatory, which is an 8.4-meter telescope. You can see the picture of the people sitting around the primary mirror there. Very large telescope. It'll be in Chile. It's being built now. The woman is holding a mock-up of the CCD focal plane there, and you'll notice that there's a little image of the moon. That tells you the scale of the camera on the sky. It's degrees by degrees. It's something I forget. It's 32 gigapixels, I think. This camera on this big telescope is going to survey the entire sky visible from Chile every few nights. And it's going to be sending out an anticipated 10 million alerts of transients, which will be variable stars, supernovae, novae, who knows what, right? All kinds of things, asteroids going by. And professional astronomers cannot follow up millions of alerts every night. There aren't even enough amateurs to follow up millions of alerts every night. So they're going to filter they're going to filter them to, by various means in software, by various criteria to try to identify, some modest number, and they haven't figured out yet what that number will be, but some modest number of particularly interesting transient events that amateurs and professionals can follow up. And the idea is that you're going to need amateurs to follow up a lot of these things because there aren't enough professionals and professional telescopes to do it. And so this is where what amateurs were doing in the middle of the 20th century, which was discovering transients that professionals would then follow up, it's going to flip. Professionals are going to be discovering virtually all the transients, and amateurs will be encouraged to help follow them up. Now, I've mentioned a lot of new technologies, and I alluded to it, the difference between active optics and adaptive optics. AO, which is how astronomers typically refer to adaptive optics, is a technology that uses high-speed computers and deformable mirrors to measure the effect of seeing on images, and then to tell the deformable mirror at a very high rate to counteract the atmospheric turbulence and sharpen up the images. And here's an example of a real AO system on the multiple mirror telescope. Well, it used to be called the multiple mirror telescope. It's now just called the MMT because it has one big mirror now. But if you see in the upper left, you have AO off. That's an image of a multiple star, Theta 1 Orionis B. They turn on the adaptive optics system, and that big blur turns into a nice sharp star, and then you see two companion stars near it, and you probably can't see it on your screen, but I can see it here. There's even a fourth companion there. So adaptive optics takes blurry images and makes them sharp. And this technology does not yet exist on amateur telescopes, but I believe that it will before long, because computers are getting so powerful, and it's the next logical step for backyard astronomers. So here's what we might have. You'd have a telescope. This example is showing a Newtonian. You have on the right side, you have a deformable secondary mirror, one that can be whose shape can be changed very rapidly. So to counteract the seeing, you have a camera that's looking at light coming off the secondary to measure to measure how the images are moving around and how they're blurring out. And that sends a signal off. The cable is going off to a high-end laptop or desktop computer, which is commanding the secondary mirror to move in such a way as to counteract the seeing. And this would enable, say, suppose you had a 14-inch telescope. The diffraction limit of a 14-inch telescope is 1/3 of an arc second, but the typical seeing that we have at our observatories is 1 to 2 arc seconds. 2 seconds is pretty common. If you have 2 arc second seeing and you turn on an adaptive optics system and you shrink that image to 1/3 of an arc second, you're basically getting 36 times more concentrated light. And that's like having a mirror that's 6 times bigger than your 14-inch telescope. And if you take a 14-inch telescope and multiply by 6, you've got a 2-meter telescope. So a system like this will turn a decent-sized amateur telescope into the equivalent of a 2-meter professional telescope. And I think this is going to happen. I don't know if it's going to happen in 5 years or 10 years. My guess it'll happen sooner than that. But this is the next technological leap, I believe, for amateur astronomers. And if we have 2-meter telescopes, the equivalent of 2-meter telescopes, then we're gonna have a great future working with professionals, a great future, a bright future in the dark. So that's my talk. Again, I appreciate your taking the time to listen and to have me here. And I know that we have a few questions, and I'm hoping there'll be some time for me to answer.